Why is data so important for artificial intelligence? So the key is that somehow inside the data there is information. So this information is something that many professions try to find inside this data. Typically a journalist will try and find the information inside its data. The clerk, which works in the legal world, is going to try and search through huge amounts of data to find information. The doctor, when trying to face a patient, will go through the history of the patient, which is just data, to try and find the relevant information. So all these are cases where the idea is to transform data into information. Data is something we learn from. So in the previous professions, we were just looking for information, but we're trying to go faster by learning rules. Doctors are going to learn from data by looking at thousands and thousands of cases. Chess players are going to play many, many games and learn from these games how to play better. And when we learn to drive, we are doing it through accumulating experience. In both these cases, we see how data is important to make decisions, to get hold of information. Data is in fact known as the petrol or the gas of artificial intelligence. Because it is used by many artificial intelligence algorithms, and because what machine learning does is take the data and transform it into rules. The systems, what we call AI systems, are trained on data. So in many, many ways, modern artificial intelligence is a step in which we are taking data and transforming it into rules, and these rules are in fact algorithms. So it is a way of going from data to algorithms in an automatic way. So when you have a lot of data, what machine learning is trying to do is find patterns inside this data and use these patterns to somehow re-encode the data. It's a bit as if what machine learning was doing was performing a compression of the data. Or in other words, we're doing a form of intelligent forgetting. We have got all this data and we would like to replace it by something much more compact, much smaller, and forget about the data. Data can come in various forms, and data can be proprietary when it belongs to somebody, to an institution, to a company, or it can be open. Data is open when it is accessible to all. This always means that you know that it is accessible. Just seeing it on the web isn't good enough. But governments are often going to encourage open data because they know that if the data is open, small companies and researchers, or really anybody, can use this data to build new applications. On the other hand, when we are working with applications which have been trained with data which is proprietary, then of course it is going to be much more difficult to openly use these applications, but more importantly, not just to use them, to verify them, to check what's inside them, and to solve the transparency questions. Of particular importance towards this question of transformation of data into algorithms is the case of large language models. These are, at least as we see it in 2023, extremely modern devices that have been making the headlines since the end of 2022. Typically, they are generative, pre-trained transformer models, and they have a huge amount of parameters to define the models. So on one hand, you have got a huge amount of data, which is just raw text. It is calculated that about 570 gigabytes of text, which comes to be about 3 billion words, have been entered into these systems. And as an output, you get a huge neural network whose number of parameters is 175 billion parameters. Since then, more extensive models have been built, one of the first being the European Blue model, which arrived in November 2022. In very short words, how does a large language model work? The idea is that these systems are trained to predict the next word. So if you're able to predict the next word, then you can predict the word after, and the word after, and the word after. One image of this is what happens when you use your mobile phone and you're given 3 words that are predicted to be what you should be wanting to use next. Suppose you always chose for the middle word, then with that system you would get an image of how the system works. Obviously these large language models are much more complex and will not only just take into account the previous word to calculate and to predict which is the next word, they will take into account a whole situation.